खुद भी लाइक कर दिया। चलिए शुरू करते हैं। जी, नमस्कार, स्वागत है आपका आज के कार्यक्रम में। मैं हूँ पूर्णिमा शर्मा और आज हम चर्चा करेंगे कि जो उत्तराखंड में सैलाब आया, उसकी वजह क्या थी? अ, हुआ क्या था ऋषिगंगा के अपर रीचेस पर? वैज्ञानिक जब वहां पहुंचे तो उन्होंने क्या देखा? कौन से उन्होंने तथ्य इकट्ठे किए? किस तरह से टूटे हुए बर्फ के टुकड़ों को समेटा? किस तरह से जो उनकी जांच है वो आगे बढ़ी? अ, किस तरह से वहां जो रॉक गिरा था उसे उसे समेटा, उसके सैंपल लिए, या हेलीकॉप्टर से किस तरह का सर्वे किया? वैज्ञानिकों की जो टीम गई गई थी वो किस तरह से, और क्या उत्तराखंड में एक और इसी तरह का सैलाब आ सकता है? क्या देखा वैज्ञानिकों ने? क्या एक और झील इस तरह की बन चुकी है जो वहां के लोगों के लिए, उत्तराखंड के लिए, ऋषिगंगा के अपर रीचेस पे क्या इस तरह की एक लेक बन चुकी है जो एक बार फिर तबाही ला सकती है? और क्या रिस्क मिटिगेशन की जब वैज्ञानिक बात करते हैं कि इसको अगर स्टडी किया जाए, उनकी मॉनिटरिंग की जाए, तो इस तरह की आपदाओं से, क्या इस तरह की ट्रेजेडी से बचा जा सकता है? इस पर बातचीत करने के लिए हमारे हमारे साथ मौजूद हैं डॉक्टर कलाचंद साइन। हमारे साथ जुड़े हैं देहरादून से, वाडिया इंस्टीट्यूट ऑफ हिमालयन जियोलॉजी में आप डायरेक्टर हैं। बहुत बहुत स्वागत है डॉक्टर कलाचंद साइन आपका हमारे कार्यक्रम में।
नमस्कार। नमस्कार
जी, तो डॉक्टर साइन, सबसे पहले मैं आपसे यही समझना चाहूंगी, वैज्ञानिकों ने हेलीकॉप्टर सर्वे किया, फोटोग्राफ्स ली वहां की, जहां से ये ट्रिगर हुआ था पूरा ट्रेजेडी, ये आपदा, ये डिजास्टर, उन्होंने वहां क्या देखा? क्या पूरा प्रोसेस रहा सैंपल कलेक्ट करने का? कहाँ पहुंची सबसे पहले वैज्ञानिकों की टीम, और किस तरह से उन्होंने इस पूरा एरियल सर्वे किया, और जो फैक्ट्स हैं, जो तथ्य हैं, जो इकट्ठे किए?
Thank you, Purnima, for giving me an opportunity to share whatever scientifically we have observed with you and your team. Sorry for this. Actually, when 7th February, this flash flood in Rishiganga catchment area took place, there are some opinions that it might have due to glacial lake outburst or glacial outburst. Since long, scientists at Wadia Institute have been pursuing research on glaciology, different aspects of glaciers they study, and they analyze the sample. They come to some conclusions, whatever has been happening on the glaciers from the climate change point of view, from other aspects, just like burning of the agricultural residue, black carbon, etc. So to understand the main causes of this flash flood in Rishiganga, a 5-member team from Wadia Institute were sent to the field. And when we talk about glaciological field, it doesn't mean at one spot, because this study has to be carried out over a larger area, and in the winter, wherever possible, our scientists have gone for the field observations, and wherever not possible, they have made some helicopter survey and got good photography. From the ground-based observation and from the heliborne photography imaging, whatever they have concluded to understand causes of this flash flood, now people have collected sample, they have come back, they have reported. So we have understood the actual cause of this flash flood. So that we'd like to share with you. Before I share these views, before I share this information to understand the main cause, I'd like to bring out the name of the Wadia scientist who spent 5 days, very important time into the field to understand this phenomena. And whatever I am sharing with this through this media, it is their work. I am only conveying. I also was a little part of that survey, went there to understand what they are telling, how much I can also understand clearly for that purpose. So the name Dr. Manish Mehta, Dr. Binit Kumar, Dr. Amit Kumar, Dr. Akshay Verma, and Dr. Sumit Tiwari. These 5 members are the people who went to the field next day after this flash flood took place. So as I told that glaciers form at very high altitude, and they are mostly inaccessible. So it is very difficult to reach the actual spot from where whatever we are containing that avalanche of glacier and rock mass and its subsequent phenomenon. So I will briefly share with you event-wise what exactly happened. First of all, the first point that a hanging glacier and rock mass avalanche took place in the Rothi Bank Glacier catchment area, and that was situated at a altitude of 5,600 meters above the sea level. I will show all these phenomena with one photograph later on, then it will be very clear what I am sharing with you. So there has been a avalanche of hanging glacier and rock mass from a height of 5,600 meter, and that rock mass as well as the glacial mass have come down along a slope, and that gradient of the slope was around 38-40 degree. So when that huge mass, and our scientists have taken a photograph after the event, and they have identified around the rock size of the rock mass will be quite good. They are estimating or anticipating that this might be of 400 to 500 meter long. So you can understand how much big rock as well as big glaciers have fallen from that distance. I will come back how they have detached from the mainland, main rock formation and main glacier after some time, when I will explain the theory of breaking of the hanging rock and overlike glacier mass. So when it fell down from that height and rolled down in the slope, which has high gradient, definitely whatever freshly formed snow were accumulated, whatever loose materials or soil existed, it also rolled down along with that, then fell down over a small stream is called Ronthi Proglacial Stream. And Ronthi Proglacial Stream is originated from the Ronthi Bank Glacier snout. So basically, the rock mass has fallen from here, and there was the river at the floor, and the river was getting fed from the Ronthi Bank Glacier, and this glacier from where it has been detached is lying on the Ronthi Bank Glacier catchment. So when this rock and this glacier mass fell down and at a height of 3,600 meter, so it came down from 5,600 meter to 3,600 meter and covered a distance of approximately 3 kilometers. And then what happened? All the rock mass, the debris, and the glacier rock fragmented and loose soil all together made a slurry, and the slurry started flowing down along the Ronthi River. So this is the first event, and when it fell down, then second event it formed slurry because the huge glaciers as well as rock mass as well as freshly formed snow as well as some sort of loose materials all scraped down to the bottom over the Ronthi River, and it formed glaciers, and that it forms slurry. That slurry material slowly went down along the downstream of the river, and that river actually is a tributary of main river, what we call Rishi Ganga River. So when the slurry flowing through the Ronthi River fell over the Rishi Ganga River, at that point, that huge slurry formed a dam type of structure, and and because of the pressure was so high, it simply broke down and further went down. The slurry material went down, and some slurry material formed a lake into the upstream of the Rishiganga river. So this is the third point. So first point, it fell down, then it formed slurry in the river Ronti, then it flew down along the Ronti river, then when it fell into the Rishiganga river, it created a dam over there, and overlying that upstream water, it formed a lake, and it went through the downstream of the Rishiganga river. So this, when it flew further down, then it met with that Rishiganga dam. We situated near the rainy village, and it made huge damage to the dam into that rainy village. So this phenomena has been observed, that how it has created that damage to the dam, and that dam around this might have what I am telling, this phenomena has taken place. That formation of the dam over the Rishiganga was around 10:30 a.m. and the rock mass fell down at around 2:30 a.m. So we have got the evidences from the local people. They heard a big blast-like sound. They thought that 2:30 there has been a blast, but our scientists have established that might have been the sound might have been due to the falling of the huge glacier ice as well as rock mass from that 5,600 meter top to 3,000 meter down into the Rothi Nala. Then when it broke that dam into when it made some sort of damage into the Rishiganga power project, that further went down, and it also carried lot of wood debris, a lot of other sediment as well as water together, and created a huge force, and that force went further down and made to the another river called Dhaliganga. And in over the Dhaliganga, when this huge slurry mass and water fell down, it created so huge impact. The water into the Dhaliganga receded back. So that means the jerk was so high that water into the Dhaliganga flowing, there was a back thrust. So suddenly there was a huge upwelling of the water into the upstream of the Dhaliganga, and that is also evidence our scientists have observed by looking into the either side of the river, and they have seen that water flown up to certain height, and then immediately, because it cannot stand there, so when it there was a back thrust of water, all huge volume of water suddenly came down, and along with the flow of the slurry, they make a huge impact to the further underlying dam, which was at the Tapovan, and we see it has made a great impact to the Tapovan dam also. So in the story, what we have seen, that at 2:30 there was a avalanche of huge glacier and rock mass from a height of 5,800 meters from the Ronthi bank glacier. Then it fell down over the Ronthi river at a height of 3,600 meters. Then with the with the rock mass fragmented, well, it came down over the slope, and the water and other debris, moraine debris together formed slurry, and that slurry made a damp-like structure in the upstream of the Rishiganga. That still we have observed through our photograph. It is existing. I'll come back after some time. What is the situation of that that lake? Then it further went down, made a huge impact to the Rishiganga dam, and further it went down and then make impact to Dhaliganga, and that Dhaliganga impact was so big because all the way whatever material it got in the top, but when it flew down, lot of other material also it got accumulated. So thrust of that material to the river Dhaliganga was so high, we observed the back thrust of the water, and that all that water that make a great impact to the dam situated into the Tapovan. So this whole whole stretch is of the order of 22 kilometers long. And we observed a lot of phenomena in that spell of time has taken place. 2:30 a.m. started, it fell down, and then at 10:30 it created the dam over the Rishi Ganga. Then afterward, this slurry and water, as it went down and down, that we have seen that definitely that huge mass of soil, debris, water, all this together, even that ice boulder, they also have the ice boulder, they have made lot of impact to the structure, to the people working into the downstream. And that we know, all of us know, that has caused really a great massacre to the people, whoever working into that region, whatever structure was existing into that region. I would like to point out over here that as we come from top to down, that in the top the river width was so small, all this material was appearing as huge height. But when it slowly came down, and width of the river got widened, the height got shortened, and that further down when it goes through the Alaknanda and other flow and different places from Devrayag to Devrayag through different other places. We see Rishikesh, Haridwar, and in between Srinagar, their water height was less. So this is in a nutshell from the evidences, whatever scientists have gathered by looking into some sort of samples, whether it is a sediment, whether it is a big boulder of ice mass. That big boulder of ice mass they have even found out at Tapovan. So all the way that after that avalanche from that height, that huge volume of glacier rock has come down, and their signature was not lost. It came down 22 kilometers into different broken pieces and have been found out even at Tapovan. Within the debris, they have found out big boulder, and their size have been rounded because of coming down all the way along the slope. So this shows definitely and concrete proof that there have been avalanche of the glacier, and number one. Number two, in between it has created a dam-like structure over the Rishikesh river, and then further it has accumulated so much sediment, wood debris, and water and other material on the way, and even newly found snow. All together, as it went down and down, it created huge thrust, and the thrust was so high over the Dhaliganga, it has created the backthrusted, and that huge volume of water suddenly created a impact to the dam in the Tapovan.
जी, तो बहुत ही अच्छे से आपने समझा कि किस तरह से ये रॉक गिरा और फिर जो बोल्डर्स आए स्नो आइस के बड़े-बड़े, उन्होंने किस तरह तबाही मचाई, किस तरह से डैम बन गया रॉथी जो अब रिवर या नाले की बात कर रहे हैं, और उससे वो आकर फिर ऋषि गंगा में मिले और फिर धौली गंगा में आकर किस तरह से पूरा ये ट्रेजेडी हुई। साथ ही साइंटिस्ट ने सब जब वो सर्वे कर रहे थे एरियल, तो क्या कुछ ऐसा भी देखने को मिला कि ऐसी और कोई ट्रेजेडी हो सकती है उत्तराखंड में, उसी इलाके में क्या कोई और लेक भी बन चुकी है जो इसी तरह का नुकसान पहुंचा सकती है?
This is a very good question, and you know that Himalayan region is so big, starting in the northwest and up to northeast, 2,500 kilometer stage and 300 kilometer width. That entire mass, that entire area, that estimated number of total glaciers in Indian Himalayan region is more than 10,000. Even in Uttarakhand itself, there are the number of glaciers are more than 1,000. So our institute, we could see some of the study, and we have made some of the study over few glacier region to understand the impact of upstream climate change, just like what is exactly happening to the glaciers, how much they are retreating, how much melt they are producing, that study. But this one is very important, that when we talk about glaciers are sitting over over some rock mass at high altitude, and what exactly happening to the underlying rock mass. That study is very, very important, because this glacier, what we are talking about, the Romthi glacier, was situated over, it was a hanging glacier, and underlying the rock mass has gone weakened. It has been weathered by the freezing and thawing process. Freezing means it just water got into solid, and when I'm talking about thawing, that means it got melted. Because of the process, that underlying rock mass has been affected, and it has been so much weathered, and it has been translated into a foliated schist rock, and it's so loose and so weakened that over that, whatever glaciers was sitting, might be over that another form of recently snow has created some sort of triggering. So this underlying rock was weakened and weathered so much that when it fell down, it was broken into pieces. Not only pieces, it broken into very small particles. So you can understand how much weather has gone, and we can see that weathered rock mass as well as big boulder. So this important question what you have asked, that from our institute we have studied over a small area, but always I say the studying glaciers into the Himalayan region is not so easy. It occurs at a very, it forms at a very high altitude, and mostly these regions are inaccessible. So we need to understand, we have not done fully. So we cannot categorically state that another type of situation may happen somewhere unless we our data, we analyze the data and come out. But definitely we cannot rule out possibility of such happening into this entire state, not only into the Uttarakhand, in other Indian states, into the Himalayan region. So there is a strong need for pursuing and strengthening our research, not only at Wadia, but many other institutes, whatever are performing. They need to have a very concerted effort, a dedicated team around the year. We need to collect some information, collect the data, and understand what is exactly happening into the region. And that way, if we can identify most vulnerable zone for such type of happening, number one, and if we can give some sort of early warning, then the damage, because these are all natural phenomena, we can't stop these natural phenomena. But what I can do, we can constitute a good team. We institute can be, work can be strengthened based to the glaciological studies, and we can find out what are the vulnerable zone and how we can provide some sort of early warning, so that the damage, so that the loss of the properties of the lives of the structure can be minimized. So that's all I want to say about whatever question you have asked to me.
जी सर, आपने रिस्क मिटिगेशन की आप बात कर रहे थे कि पहले से ही अर्ली वार्निंग सिस्टम हो जिससे इस तरह की घटनाओं को रोका जा सके। इसके लिए ग्लेशियोलॉजिस्ट की बड़ी टीम की जरूरत होगी, ज्यादा रिसोर्सेज की जरूरत होगी। आपने चर्चा की कि किस तरह से इतना आसान काम नहीं होता ग्लेशियर्स को स्टडी करना, क्योंकि इनएक्सेसिबल रीजन होता है जहां जाना मुश्किल होता है। अभी भी इस दौरान भी बहुत सारी ऐसी जो ये ट्रिगर पॉइंट था, वहां तक पहुंचना भी वैज्ञानिकों के लिए इतना आसान नहीं रहा होगा। हेलीकॉप्टर सर्वे किए गए। साथ ही जब इंडियन हिमालयन रीजन की बात आती है तो कई स्टेट्स हैं जहां इस तरह की घटनाएं हो सकती हैं या वो इसके लिए प्रोन है। तो वहां की सरकारों को किस तरह से, जिस तरह आप कह रहे हैं कि कंसर्टेड एफर्ट करने की जरूरत है, सबको मिलकर इस पर काम करने की जरूरत है, खासतौर पर वो राज्य, वो इंडियन स्टेट्स जहां जो हिमालय से सटे हुए हैं, वहां इस तरह की मॉनिटरिंग होना जरूरी है ताकि जान माल को नुकसान ना हो। 10,000 से इंडियन हिमालयन रीजन में 10,000 से ज्यादा ग्लेशियर्स हैं और इस तरह की स्टडी वहां की जानी चाहिए, मॉनिटरिंग लगातार होनी चाहिए सर वहां की।
Yes, Purnima. This is very much required monitoring, and again I say that since this region is quite big, and if we really want to have a concerted effort, what I mean that whatever states are attached to the Indian Himalayan region, wherever we see these glaciers, and that state first-hand information they can get from the satellite data, remote sensing data. Remote sensing data will be able to understand lot of features, even if their area is inaccessible. But to give a ground truth validation wherever possible, and each state would have a team or dedicated institute. They can understand from the ground observations and from the satellite data and make a comprehensive understanding what exactly happening to the glaciers from the upstream climate change, what exactly happening to the downstream, what exactly happening to the rock formation. So what I want to say concentrated effort means all the states, Indian states attached to the Indian Himalaya, wherever we have glaciers. And just like take the example of Uttarakhand. So if we have our dedicated team constantly, we study and all the data set, whatever we are collecting from the ground-based observation, whatever we are getting from the satellite data, and if we have a collected data at one place and give some sort of thought of what process has gone and how we can understand the vulnerability, then it will have a great impact to understand the phenomena, what has been going on into the Himalayan glaciers. So if we take the care of our local problem and all the local problem, if we just place side by side, then we'll have the all Himalayan regional problem, and then from the regional problem centralized, there should be some central monitoring system. And if this from the center, once we get the input from all the states, but state will be doing their work, this state will be doing this state, and all, if they give information to the center, and there will be centralized monitoring system, centralized monitoring team, and then I think we will be able to do the justice what exactly happening to our Indian Himalayan state.
जी, तो मेरा अंत में आखिरी सवाल सर यही होगा आपसे कि इंटरनेशनली किस तरह से आपने अर्ली वार्निंग सिस्टम की बात करी, तो कंसर्टेड एफर्ट्स की बात करी, राज्यों की, और उनका कोऑर्डिनेशन होना चाहिए स्टेट्स के साथ, इंफॉर्मेशन जो है उसका फ्लो होना चाहिए, कोऑर्डिनेशन रहना चाहिए। ऐसे में इंटरनेशनली भी इस तरह की जो परिस्थितियां होती हैं उनसे कैसे टैकल किया जाता है, कितने रिसोर्सेज की जरूरत होती है, कितने संसाधनों की जरूरत होती है, given kind of the length and the breadth of these and the जो इस की हम बात कर रहे हैं कि कितना रिस्क है इन इलाकों में, खासतौर पे इंडियन हिमालयन रीजन में ये प्रोन है इस तरह की घटनाओं के लिए, तो इंटरनेशनली किस तरह से अप्रोच किया जाता है रिस्क मिटिगेशन के लिए, अर्ली वार्निंग सिस्टम के लिए किस तरह की तैयारी होती है और कितने रिसोर्सेज की जरूरत पड़ती है, क्योंकि इंडियन हिमालयन रीजन बहुत बड़ा एरिया है, बहुत बड़ा इलाका है, बहुत बड़ी टेरिटरी है, तो उसको अगर मॉनिटर करना है तो कितने रिसोर्सेज की जरूरत पड़ेगी और किस तरह की बड़ी तैयारी की जरूरत है?
देखिए, वर्ल्ड का और भी डिफरेंट कंट्रीज ग्लेशियोलॉजिकल के ऊपर जिस तरह से स्टडी कर रहा है और इंडियन साइंटिस्ट हम लोग जिस तरह के स्टडी कर रहे हैं, उसमें बहुत करीब अंतर होगा। इसलिए अंतर होगा एक्सेप्ट country which is directly situated into this Himalayan region. If we keep them aside time being, if we talk about other countries working into the glaciological area, their glaciers are different from our glaciers, particularly the countries working into the Arctic and Antarctic. These glaciers are being affected only by the upstream climate change. But when we talk about Himalayan glaciers, the third pole, this has a different type of activities. It is getting affected by the upstream climate change, as well as there are some activities going on beneath the Himalaya. So there will be some sort of sometimes some warm fluid may come, hydrothermal is there, geothermal is there, so they will also have some impact from the burn. So here studying in the Indian Himalayan region, first of all, you have very rightly said the region is very big, and they are remaining in some pocket, particularly Arctic and Antarctic. But like that, wherever we have situations like Himalayan situation, the part of the portion the country is dealing with is much smaller than the Himalayan part. The long stretch is being covered. So the main problem lies in our country that the resource that the not only human resource, but our infrastructure, but our very, very inhospitable compared to other region is little different. Himalaya is very, very complex. It both not only both laterally, vertically, very, very complex phenomena is going on. And even if we have huge human resources and very good network of infrastructure to collect the data, then also unless we with the local people, local institute, local scientific organizations, they need to come forward, and they need to concentrate their study a different way than different states. So each state should concentrate completely and dedicatedly to understand the process. Then what I have explained, then if we join them together, this is possible because of our large heterogeneity. Even if type of work we will be pursuing in Uttarakhand region, and when you go to Himachal, when you go to Jammu Kashmir, the situation will be different. Even we have understood that the glaciers in the Jammu Kashmir Karakoram region, it has experienced such type glaciers. Here we have seen hanging glaciers. Last time, whenever we saw that Kedarnath disaster, that glacier is a valley glaciers. So different type of glaciers exist in different terrain of the Himalayan complex region. So study of a Himalayan glacier, that's why I'm telling repeatedly that even if we employ huge human resource, huge infrastructure, we also look into this regionally much more than as a whole Himalaya. So if we have, that's why repeatedly I am telling that our concerted effort, concerted team should understand the geological process, the tectonic process, the glaciological phenomena completely into that region that may be different from this region to another part of the Himalayan region. So that way, if we plan, I think we'll be able to make a success to save not only to the properties during any sort of disaster, not only the Himalayan glaciers. Himalaya is prone to have different type of disasters. All of us know. Just yesterday night also. So we have understood that phenomena, earthquake, and that Himalayan region is prone to have earthquake, prone to have landslides, prone to have other type of flash floods. Not only these flash floods, there may be heavy rainfall, excessive rainfall. Now these extreme events are there, and Kedarnath we have seen that type of phenomena, but here we have seen different phenomena. There we have seen in Kedarnath that there is a cloud burst. So cloud burst again have made the glacial lake outburst. Here in this region, we have not observed, our scientists could not find out any glacial lake outburst. Here, there have not been any evidences of the rainfall. So we see that entire Himalayan state is so complex, and the phenomena is also so complex. So unless we study clearly into that region, we will not be able to understand and provide some sort of monitoring, whether some sort of other information about the vulnerability, etc.
जी बिल्कुल. तो हिमालय रीजन जो है वो अपने आप में, इंडियन हिमालयन रीजन बहुत ही बड़ा है, और अलग अलग जो राज्य हैं वहाँ अलग अलग चुनौतियां हैं. कश्मीर की बात करें तो वहाँ अलग चुनौतियां हैं. अगर हम नॉर्थ की तरफ चले जाएं तो वहाँ अलग तरह की चुनौतियां, हिमाचल में अलग हैं, उत्तराखंड में अलग हैं. जिस तरह आपने कहा कि केदारनाथ में लेक, वहां पर क्लाउड बस्ट हुआ, फिर ग्लेशियर लेक बस्ट हुआ, और यहाँ एक हैंगिंग ग्लेशियर की अलग बात थी. इस तरह तो अलग अलग रीजन है, अलग अलग चुनौतियां हैं. तो जरूरी ये है कि हर राज्य अपने स्टेट से अपने रिसोर्सेस को वहां लगाए, और वहां हर अलग अलग स्टेट में, अलग अलग इंडियन स्टेट को अपनी जिस तरह की हिमालय रीजन में जिस तरह की चुनौतियां हैं उनकी मॉनिटरिंग करें, वहां एक टीम डेडिकेट करें, और इस तरह से इस आपदाओं से बचा जा सकता है. इनकी लगातार मॉनिटरिंग होनी चाहिए. हिमालय जैसा हम जानते हैं बहुत ही सेंसिटिव रीजन है, और एक मिलकर एक कंसर्टेड एफर्ट होना चाहिए सबका, जिससे इस तरह की आपदाओं से, इस तरह की ट्रेजेडीज से बचा सके. तो बहुत बहुत शुक्रिया डॉक्टर कलाचंद साइन, डायरेक्टर वाडिया इंस्टीट्यूट ऑफ हिमालयन जियोलॉजी, हमसे बात करने के लिए, और बहुत ही विस्तार से इस विषय पर हम हमारे दर्शकों, हमारे व्यूअर्स को जानकारी देने के लिए बहुत बहुत शुक्रिया. धन्यवाद.
थैंक यू मैडम. थैंक यू.